Hello everyone, and welcome back to my channel. Today, I will show you how to solve two trigonometry problems step by step, and I'll also share a trick to help you remember the unit circle more easily so you won't get stuck on these problems again. A viewer submitted these problems, so if you'd like to see your problem or concept featured in a future video, drop it in the comments below. I'd love to make a video on it. With that out of the way, let's get started. The problems we'll be solving today are 1. Find all solutions to the following equation. 5 sine theta plus 1 equals 3 sine theta. And 2. Find all solutions of the equation tangent x equals 1. These might look tricky at first, but once we break them down and use the unit circle, you'll see how quickly we can work through them. Let's start with labeling the unit circle. I've drawn the unit circle off camera and labeled all the key angles, the axis intercepts like 1, 0, 0, 1, etc., and left blank x and y coordinates at each key angle. Now, let me show you a trick for quickly memorizing the unit circle values at each of these key angles. So we're going to start in quadrant 1, and we can use those values to fill in the rest of the other quadrants. So first, create fractions with a denominator of 2 for all x and y values. So like this. I'll do the rest off camera. Now that we've done that, the next step is for the x values, write the numbers 1, 2, and 3 in the numerator going down. So I'll show you what that looks like. So we'll write the numbers 1, 2, and 3 in the numerator of the x value going down. Then for the y values, write 1, 2, and 3 in the numerator, but this time go up. So 1, 2, and 3. Now finally, the last step is to take the square root of each numerator. And since the square root of 1 is just 1, I'll write that as 1. And I'll do these off camera. Now we have all the x and y values at each key angle in quadrant 1. Now repeat these steps for quadrant 2, except make the x values negative, since all x values are negative in quadrant 2. So I'll do this off camera. Alright, great. Now we have quadrant 2 filled out, so let's focus our attention to quadrants 3 and 4. So we still create fractions with a denominator of 2 for all x and y values. So I'll do this off camera. Alright, so I filled in the denominator of 2 for all x and y values. But now this is where we have to pay super close attention because one of the steps is going to change. So do you remember how I told you to go 1, 2, 3 in the numerator for the x values, and that was going down? And for the y values, go 1, 2, 3 in the numerator going up. Well, now we're going to do the opposite of that for quadrants 3 and 4. So what do I mean by that? So that means for the x values, write the numbers 1, 2, and 3 in the numerator, but this time go up. And for the y values, write the numbers 1, 2, and 3 in the numerator, but this time going down. So I'll show you what that looks like for quadrant 3. So for the x values, we write the numbers 1, 2, and 3 going up. So we'll have 1, 2, 3 going up. And for the y values, we have 1, 2, and 3, but this time going down. So 1, 2, and 3, just like that. And I'll fill this in on the other side for quadrant 4. Now that I filled that in, the next step is to take the square root of the numerator for all the x and y values. So I'll do that off camera now. And so now our last and final step to complete this unit circle is just to account for the signage in quadrant 3 and quadrant 4. So in quadrant 3, both the x and the y values are negative. And in quadrant 4, only the y values are negative. So let me put all those signs in now. And with that done, we have completed our unit circle and filled in all the values for each of the key angles. So I hope you guys enjoyed that, and I tried something new. I tried doing some of this stuff off camera to save some time, so let me know what you guys thought of that in the comments below. But now we're ready to use this to solve our two problems. So let's first solve problem 1. So we're asked to find all solutions to the following equation. 5 sine theta plus 1 equals 3 sine theta. So first of all, we can combine like terms by subtracting 3 sine theta from both sides, like this. And on the right hand side, this will cancel. And on the left hand side, we're left with 2 sine theta plus 1 equals 0. And so now if we subtract 1 from both sides, left hand side, the 1 will cancel, and we're left with 2 sine theta equals negative 1. And then if we divide both sides by 2, on the left hand side the 2 will cancel and make 1. And on the right hand side we'll get negative 1/2. So we'll have sine of theta equal to negative 1/2. So now we need to ask ourselves, for what values of theta does sine theta equal to negative 1/2? To answer this, we can turn to our unit circle and find where sine, the y-coordinate, equals negative 1/2. Looking at our unit circle, we can see that sine, or y, equals negative 1/2 at 7 pi over 6 and 11 pi over 6. So that gives us two solutions, so let's write those down. So I wrote down those two solutions, but we're not quite done yet, as we're asked to find all solutions. To include every possible solution, we have to attach plus 2 pi n, where n is an integer and represents the number of full revolutions around the circle. So I'll clarify what I meant by that in a second, but let me first attach the plus 2 pi n to both of these solutions. So we have 7 pi over 6 plus 2 pi n and 11 pi over 6 plus 2 pi n. So let's say we go around one full revolution. That would be where n is equal to 1. So 1 revolution is equal to 2 pi, right? So 2 pi times 1, we go around 2 pi radians, right? If we did that, we would end up at the exact same angle, and that exact same angle would give us sine theta is equal to negative 1/2, where theta is our, in this case, 19 pi over 6, right? So to account for every possible solution, we have to attach this 2 pi n, again, where n is an integer that represents the number of revolutions we're going to make from that angle. So, I mean, if n was 1,000,000, we would still, even though it'd be a really, big number for our angle, it would still give us negative 1/2. So that is why we have to include our 2 pi n here to include all solutions. And these are our two final answers right here. So let's put a satisfying green box around them. So now let's look at the second problem, where we're asked to find all solutions of the equation tangent x equals 1. So let's think about this a little bit. Tangent x equals 1. Well, tangent x is equal to sine of x over the cosine of x, right? But in this case, we have to set this to equal 1. So for this to be true, sine of x has to equal cosine of x. And to find out where that's true, let's look again at our unit circle. Going back to our unit circle, we have to find where sine of x, which is the y-coordinate, and cosine of x, the x-coordinate, are equal to each other. And I see two solutions here. I see one at pi over 4, right, square root 2 over 2, and square root 2 over 2. And I also see one at 5 pi over 4, where we have negative square root 2 over 2 and negative square root 2 over 2. So let's write down those two solutions. So now we have two angles where tangent is 1, pi over 4 and 5 pi over 4. But here's the interesting part. These two angles are exactly half a circle apart, or pi radians. So instead of writing both solutions separately, we can describe them all using just pi over 4 and say x equals pi over 4 plus pi times n, where n is any integer. That way, if we plug in n equals 0, we get pi over 4. If we plug in n equals 1, we get pi over 4 plus pi, which equals 5 pi over 4, and so on. So 5 pi over 4 doesn't need to be listed separately. It's already part of the solution x equals pi over 4 plus pi n. So we can actually erase this second solution and put a green box, around this solution here. And that's it, everybody. I showed you how to quickly find all x and y values on a unit circle, and we solved both problems using that unit circle. We also talked about why we include plus 2 pi n and plus pi n in our solutions to account for all possible solutions. I really hope you enjoyed this video. If you did, please leave a like and share it with someone you think could learn from it as well. Consider watching another one of my videos to continue learning. I'll link my last trigonometry video in the end screen, which I just wanted to thank you all for the support on. That video is performing really well, and it really means a lot to me to see you guys liking and supporting the content I'm giving you guys. So let me know in the comments if you have a problem or concept you would like to see covered, and subscribe for more math and educational content. Have a great day, everyone.